Final topic in Chapter 1 is equivalence conversion factors. So an equivalence conversion factor allows us to convert between different types of units. So previously we talked about conversion factors that were about the definition of a unit. The relationship is always the same between, say, a centimeter and an inch, because those are just defined units. Equivalence conversion factors are then going to be relationships between unrelated units based on a given situation. So we already seen this actually in the density example. We were able to relate mass and volume for a given substance, right? We were looking at ethyl alcohol there, right? We can relate that back and forth. Another example would be something like a speed. If you are going 60 miles per hour, again, that per hour implies that there is a 1. So 60 miles, that distance is the same as saying that 1 hour passed. This relationship in general is not true. If you are not traveling 60 miles per hour, it's not true that in 1 hour you travel 60 miles, right? If you are traveling a different speed, I'm not moving 60 miles per hour right now, so this is meaningless to me. But if that is true of, then that allows you to do that relationship. That mass to volume relationship we just did is only true for ethyl alcohol, not all substances. So it's going to be based on, and anytime you have a compound unit, you can do this, because compound units always have that per. There's that per when you have that ratio in your unit. And so you can always do that. You can also have unique setups that let you do this. They're just equivalences, they're just defined to be equivalents. So for example, it's found that 100 milliliters of a patient's blood contains 0.125 milligrams of drug. That allows you to do a relationship. 100 milliliters of blood contains 0.125 milligrams of drug, right? So in this case, not only do you have specific relation between different types of measurements, volume and mass, it's particular volumes of something. It's a volume of blood and a mass of drug. And because those are equal to each other, you can then use that relationship to develop your conversion factor. You can go from milliliters to milligrams or milligrams of drug to milliliters, right? The question is, I want to know there's 100 milliliters, there's 0.25 milligrams in 100 milliliters. Well, how much drug is in the entire body, right? Across the entire, whatever volume of blood is in the body. Or what if I want a certain amount of drug, how much blood do I need to draw in order to obtain that much mass of drug, right? I want 0.5 grams. Well, what volume of blood do I need to obtain in order to get that? Or would the patient need to have in order to reach a certain threshold of danger or something like that? Let's look at an example that's a little less scary. The cost of silver is $19.54 per ounce. What is the cost of 1.45 pounds of silver? What units do we want? So we can see if we read out the question, what is the cost? So you need money, dollars, cents, if you want to convert it to another currency, but it needs to be a money. What units do we start with? So we're really tempted when we see this dollar sign to think that that's what we're going to start with. But in reality, that actually is not what we start with. And we can tell it because there's this per. It's $19.54 per ounce. That is a relationship between two different types of units. What I want is just cost. I want cost. That's a reference to how much we have. And we are told it's a cost of my 1.45 pounds of silver. So weight or mass is what we're looking at here. This 1.45 pounds of silver is our starting point. We want to go from a weight representation into a cost representation of my amount of silver. And the per is what's going to let me relate those. Similarly, when we're looking at here, think about what conversion factors connect those start and end points. Once even if we didn't notice the per and all that stuff, when we know we want to go from weight to cost, we can say those two things are not normally related, right? There is no generic relationship of dollars to pounds of anything. and it's going to be based off of something that's specific to my material or what I'm looking at, right? A pound of water costs very different from a pound of printer ink. And so they have different relationships. And that's where this equivalence conversion factor comes in. One of the things that makes equivalence conversion factors tricky is ironically, is that they're in the problem. And so it ends up seeming like it's kind of smoke and mirrors. There's this extra number that's just in there that is needed to complete the problem. You have to know that it's $19.54 per ounce of silver, but that is, what you use to convert or modify your other numbers. So with all this in mind, let's actually work it out, see how it goes. Cost of silver is $19.54 per ounce. What is the cost of 1.45 pounds of silver? So we know we want cost. And so it's likely that we're going to start in dollars. And so the thing is, this is something that has to be a unit conversion. We don't have any equations to turn to. So this is why we have to use these sorts of, this is definitely a conversion problem. So our likely ending unit is going to be dollars because we can see dollars is there. We can maybe convert to cents if we wanted to or whatever. And so just like with density, that per grams per milliliter indicated that that was a conversion factor. That per means likely a conversion factor. That this 1.45 pounds is where we're starting. Okay, so 1.45 pounds lb of silver. That is definitely where we are starting in this case. We're going to try to convert that into money. Okay. So pounds and dollars, generally, those are entirely different measurements. Just like we saw previously, there's unlikely to be a direct relationship that we can look up. This is a pound costs this much money. That's definitely not true in general. It's going to be something specific to silver. And that's where this idea of equivalence conversion factors comes up. It has to be something uniquely defined for what we're looking at. And so we can see in this case, there is a monetary relationship, the cost of it here. So, the idea of dimensional analysis, we know that this last conversion factor, the units on this has to be dollars. We don't have a direct dollars to pounds comparison or relationship. So what do we have a dollars for? Well, it's 1954 per 1 ounce. Right, that is defined by the unique situation. That's what makes it an equivalence conversion factor. One of the things about equivalence conversion factors is they're always going to be given to you. They're always going to be listed. This number is equal to this number, or this per this. And so we can always use those. So then the question becomes, we're using our equivalence. Well, now, can I put in this relationship? I know I need to get rid of the pounds. I got to drop my lbs. And so I need to then go into ounces. So the question is, how can I relate those? And you may know it. It is a customary conversion that's just the definition, that 1 pound is 16 ounces. But because this is customary, you could always just look it up. And so if we look at our units now, and this is true for more than silver. I guess I probably should have written silver in there, but pounds cancels out pounds. It becomes ounces of silver. So those ounces would cancel out, and what we'd be left with is dollars. And so we can do our multiplication in a more complicated one like this. We'll write out the actual, we'll do purple, I guess. It's going to be the actual arithmetic is 1.45 times 16 times 1954 divided by 1 times 1. So all this multiplied by all the numbers across the top divided by all the numbers on the bottom. So we can do that arithmetic and we'll get an answer. The question is, how should we round it? We may be tempted just to go to like the 1 cent place, so point something like to match that. But this is multiplication. We can use our sig figs. And so we can look to see that 1.45, that is 3 sig figs. There's no zeros there. This is a customary to customary conversion. This is a definition. Just like metric to metric, these are going to both be exact. Customary to customary are exact measurements, so they just simply go across. This one is also exact. Whenever we see that word per ounce, that's exact. 1954, that is 4 sig figs. Maybe tempted to call that number exact, but you can have fractional cents for costs, especially on something that's being traded, like say, for example, silver. So that is in fact 4 sig figs. It's only reported to cents, but you could have more specific things. You can have half a cent costs, third of a cent costs, or whatever, especially on a resource like silver. So our answer then, 4 sig figs, 3 sig figs, needs to match that. That one is lower. So if we multiply everything together, we get $453. Oftentimes people just round to dollars in this sense, or in this case, not necessarily for sig fig reasons, but motivation. But that is a big motivation, is to, we can kind of understand that, this is really precise because it's an ounce. That's a really small mass, a really small weight. 1.45 pounds is much larger, and the value is much larger. So you don't necessarily have as much resolution to cents out to this. But 1.45 pounds is a bigger volume, so that is less resolution. And so bigger mass, sorry. So that's less resolution. So your cost is going to be to less resolution. You don't necessarily know out to cents. If you wanted to know out to cents, that's going to cost, you would need a more 1.45, whatever, 6, 7, 8, whatever, and another digit to get down to single cents. So, but we can work through it. And that equivalence conversion factor, we're going to identify those really when it's like there's no other way that these things are related. They're going to be unique. So if we're told something has a compound unit, we saw grams per milliliter with density, dollars per ounce in this case, or anytime where you're told this equals this for this particular case. It needs to be a setup where these two units are not normally related, but for this particular case, there is a relationship between them.